Want to create a professional academic thesis with ease? Then you've come to the right place. Too many students rely on outdated templates or wrestle with Microsoft Word only to end up with formatting issues when compiling large documents like a thesis. In this video, you'll learn how to build a fully customized academic thesis from scratch, how to add structured content, insert your bibliography, design a custom title page, and even break your thesis into clean, modular files, making your document easy to manage and edit. Everything here is hands-on, practical steps that you can follow along with and build your own thesis as we go. This section is just one part of the full LaTeX Complete Course, which is available for you to sign up at www.innovedacademy.com. There, you'll learn to go even deeper with LaTeX, create beautiful figures, add aesthetic tables, typeset math equations, add code snippets, and more. So grab your LaTeX editor and let's get started building a custom academic thesis that stands out. In this next section, we are going to take a look at how we can write a custom thesis in LaTeX. And as part of this section, we will cover the following. So we'll show how to create a thesis and add the main content. We'll also show you how to add a bibliography to your thesis. We'll do that by adding it in an external.bib file. And we'll look at how we can customize our thesis, things like the page layout, the fonts, have a custom title page that would suit a thesis, which would be a bound printed book. And our overall goal here is to create an easy to customize and a maintainable thesis. And in order to do that, we will split our main.tex file into multiple different files. So we'll use separate tex files for each chapter, chapters 1, chapters 2, and chapters 3, or however many chapters you need. We'll also have a separate tex file for an appendix, and we'll also put the bibliography references will be defined in a references.bib. And then we will also create a custom document class called my thesis, which will house the style and the formatting of our thesis. And as a result, we'll have a clear separation in our files between the style and formatting and the content. So all of this stuff here, all of our .tex files will be the content. And that is useful because then you will have a reusable document class file, the My Thesis document class. And it means that you can focus on the content when you are writing the content. Now I'll show you here the actual end thesis, which we will produce. So this is the actual final thesis. So you can see here it has a custom title page with a university logo. Then we have all the main sections of a normal thesis, a declaration, abstract, acknowledgement section, table of contents, list of figures, list of tables. We'll add a very short nomenclature, which is where you put the different math variables you use and their definition. And then we will add the main content. This is, of course, all lorem ipsum filler text. We have a chapter 1 and we have a chapter 2. And you'll notice here as well, we've done stuff like customize the fonts, customize the title or the section formatting. Up here is the front matter, and we actually have it set up so the page numbering is in Roman numerals in our front matter. And here as well, the page margins are wider in this part of the thesis. And you'll also notice the inner margins, which are here, are bigger than the outer margins. So then you can get your thesis bound. So this would be a two-sided printed version of your thesis. And if I come down to, say, the main matter, we've done stuff like reset the page numbering back to Arabic numerals, number 1. And also you have smaller or reduced, more narrow page margins, basically. And this is the main matter. And then we have a chapter 2 where we add some figures as well. And we add some tables as well. And we customize these tables a little bit. And there's a chapter 3. And then finally, we have a bibliography. So we'll cover the bibliography and an appendix section as well. Now, in our main.tex file, by the time we get to the end of this, what it will look like is we will actually have a very simple main.tex file. You can see, although we have quite a lengthy document, the main.tex file is quite short. And how we have accomplished this is, you can see on the left, we have split our thesis into separate files. So there's a main.tex file, which is short, and then within that, I'm able to include other tex files for our chapters, We use a references.bib file for the bibliography, and we also create this custom document class called my thesis, which controls all of the style and formatting, which is written in a custom document class. And all of these files we will create from scratch. The other nice thing about the way that this is set up is that, say, sometimes you want to create a two-sided printed version of your thesis, and if you want to do that, you can set an option two side. Sometimes you want to create a one-sided printed version of your thesis, then you can set an option here, one side, and maybe also you want to create a correctable version of your thesis. We have set those options in this custom document class. So if I, for instance, rebuild this, we'll get the correctable version of this thesis. As you can see, we now get the line numbering up the left-hand side, and we have increased line spacing. It now goes to double line spacing. So you can see here, there's chapter 1, and you have these line numbers up the left-hand side. And of course, one-sided printing has a different setup to two-sided, has a different setup to if it was an online PDF, because you set up one-sided and two-sided so that the actual printed version can be bound, unlike the online version. So anyway, without getting into too many of the details, and without further ado, let's get started and jump into creating this thesis. In this lesson, we are going to add the main content into our thesis. As a result, we will end up adding a simple title page. And as well as this, we will also add some custom environments, such as this one here. So we'll create a custom declaration environment in order to add this section that we have here. And basically how this will work is we will add a custom environment, and in its definition, we will add a section with a name declaration. And then we'll also add this bit at the end to add a signed and date part, which you would normally have in a thesis. And of course, we're doing this so that we can keep our main.tex file simple, and then we'll go on to add this custom environment to a custom thesis class so that we can separate form and style. In the same manner, we'll add the other common sections that you normally have in a thesis. So we'll add an abstract, which is normally done with the begin abstract and end abstract environment. Similarly, for an acknowledgement section, we'll create another custom environment, but instead of creating one called declaration, we'll create one just called acknowledgement, begin acknowledgement, and same thing down below, we'll have end acknowledgement, just to add this very similar section, similar to an abstract section. As well as this, we'll add a table of contents using the table of contents command, and we'll also add a list of figures using the command list of figures. And we'll do the same thing for tables. We'll have a list of tables, and again, there's a similar command, list of tables. Now, another common section that you can have in a thesis is a nomenclature. And typically what is in this is a list of the different math variables you use throughout your document. So we might be using T for time, V for velocity, X for displacement, and you can see they're all written in italic in the normal math font because they're all math variables. And then you have a description of each of these. T stands for time, V stands for velocity, etc. And in order to do this, we will create yet another custom environment, and this is an example of how that environment will then work. And again, this is to keep our main.tex file and our document environment very simple and just focus on the content. And we'll set this nomenclature environment up so that it works kind of similar to the tabular environment, in that we'll separate the different content, this is the content here, with ampersand symbols, and then we'll jump to new lines with double backslash. So we'll nest a tabular environment in the definition of this in order to do that. And then for each of our math variables, we create all of these custom commands to store them. As you can see here, they're all called math time, math velocity, math displacement. That's what's printing these actual variables over here of T, V, and X. And as a result, it'll be really easy if you want to ever change what symbol is used to represent these variables in the future. So we'll cover that. And then going past nomenclature, we'll just go on to fill out the other contents and bits and pieces of our thesis. So we'll add an introduction chapter, a main content chapter, we'll add some figures, and we'll also add a subfigure, and then we'll also go on to add some tables. Now, when we get on to adding our own tables, what we will do, again, to keep our main.tex file simple and for it to be focused on the content, we will create a custom tabular environment, and we will call it my tabular, and we will use it to style tables as we want. So you can see here, this table or this tabular environment, it's styled with alternating row colors of light gray, white, and we have a certain style applied to our heading, and we've also stretched it out vertically a little bit, and we're also actually modifying the default thickness of the lines, and all of that style and formatting is mainly nested in my tabular, and it's also nested in this custom command called head. And then in the remainder of this thesis, we'll just fill it out. So it's a full example. So we'll just add a conclusion chapter, and we'll also add an appendix chapter. So mainly here, what we're doing is adding the main content and adding some custom environments. In later lessons, we will customize the style and formatting a lot more, and we'll create our own class file to house these custom environments that we add. So let's now jump over to Text Studio, and back in Text Studio, we'll start by creating a new file. So I'll hit Control N to create a new file and Control S to save this somewhere on our computer. And I'm just going to create a new folder here, which will be our working project folder. And I'll call it Academic Thesis. And then I'll open that folder and I'll save our file as our main.tex file. And the first thing we must do here is decide what document class we're using. I am going to use the report document class so that I have access to the chapter commands. And then I'm going to use the package lipsum, which we will use throughout our document for adding some filler text. And then I will add our actual document environment. And the first thing I want to do here is add a simple title. So to add a simple title, I'm just going to use the make title command. Of course, in order to do that, I have to actually define the parameters of the title. So I'll add a comment, define title parameters, and this is done using the command title, and then we pass the name of our title as an argument to this command. So I'm just going to title this work, "This is my title," and then we also must define an author. So I'll say the author is John Doe, and then we must also set a date. So I could set the date as well here using the command today, or I could have just typed a date manually here as well. And with our title now defined, we should be able to build and view our output, and we get this one-page document with a pretty simple title. The next thing that we'll look at adding is a declaration section, which might be one of the first sections in an actual thesis. So I'll do that using the section command with a star, so it'll be an unnumbered section, and I will just title this as declaration, and I will populate it with some filler text. And normally at the end of a declaration, you have a little part where you put signed, and then your name and the date, and it's there for declaring that you've actually written your own thesis. Normally what the text that you put here is, "I solemnly swear I have actually written this thesis and done the work in it," but for the moment we'll populate it with the lipsum command. So to add the signed and date part, what I'll do is I'll add a tabular environment. So I'll go begin tabular, end tabular, and I will use a left aligned column and a center aligned column in our column spec. So I use L and C. And then as our content, I'll put the word signed followed by a colon, and then I'll put an ampersand to jump to the next cell and a double backslash to jump a row down, and here we'll put date, and I'll put semicolon, and I'll do the same thing, ampersand, double backslash. So this should give us the start of a declaration section in our output, as you can see, but we should be able to improve upon it a little bit. You can see we have our signed and date part here. It would probably be better if there was actually a little bit of vertical space between this and the content. So I can add some vertical space there using the vspace command, and I will jump down a length baseline skip, which is the height of one row of text. And if I rebuild this, that should push our signed and date part down a little bit. And the other thing I'll do here is I'll create a horizontal line. So I can do that by using the H space command to create some dead horizontal space. And let's say it's 3 centimeters in length. And then if I nest that entire command within the underline command, that should create a horizontal space of 3 centimeters with an underline. So as a result, we should get this underlined section, and I'll repeat it for the date part. And we should get this underlined section where someone can actually physically write down their signature and their date, as you can see here. The next thing I'll do here is I'll just space these out a little bit vertically, and that can be done just before our tabular environment. I can renew the command array stretch, and I'll set it to 1.25 to stretch this tabular environment out 25%. And the final thing I will do here, you can see our tabular environment is pushed to the right because it's basically being indented. So to remove the indentation, I can use the command no indent just before the beginning of our tabular environment. And if I build this now, we should push the signed and date part to the left. And now we have our declaration section. But as you can see in our main.tex file, we've had to expand on the commands, and now our main.tex file and our document environment here is a little less tidy and is less focused on the content. And I want to keep our content and our style and formatting separate. So in order to do that, what I'm going to do is turn this into an environment so that I can simplify the syntax that we use down here in the document environment. So in order to do that, what I'm going to do up here is I'm going to create a new environment. So I'll just add a comment and I'll just add a section to our preamble for custom commands and environments. So I'll put here custom environments, and then I'll comment create a custom declaration environment. And to create a new environment, we can use the command cold new environment, and we will give our environment a name. We will name it declaration, and then we must give it a beginning definition as well as an ending definition. And if I come down to how we created our environment, the beginning definition and the end definition are always separated by the content. So if I look at this, our content is going to be the lipsum command or any other text, which means this is my beginning definition. So I can cut that and paste it into the beginning definition. And this lower part here, all of this is our end definition. So I'm going to cut that and paste it here. So all of this should be our declaration. I'll also actually add a page break at the end of this so that nothing else goes on this page. And as a result, we should now have a new environment called declaration. So if I were to come back down to our document environment, I can write begin declaration, as you can see, and then I'll just paste this lipsum command into it, and I'll just delete some of the dead space here. And if I rebuild this, you can see it builds almost as normal, except that we have lost our vertical space. So we just need to alter our definition for that. And to correct this, what I'll do is I'll just add a double backslash within this beginning definition, and that should move the signed and date part back down. So now we have our declaration environment is working correctly, and we have kept our document environment focused on the content. After our declaration section, we can add an abstract using the begin abstract and end abstract commands. And then as our content, I'll just put more lorem ipsum filler text using the command lipsum. So this time we'll go lipsum 224 to give us several paragraphs of lorem ipsum filler text. And as a result, we get our abstract section down here. And after this, we will add an acknowledgement section. There is no existing environment in LaTeX for an acknowledgement section. So in this case, I'll use section with a star to create an unnumbered section, and we'll title it acknowledgements. And then I'll also add some more lorem ipsum filler text here. So this time I'll go 4 to 6 maybe. And I'll also add a new page command just to ensure that the acknowledgement starts on a new page. So if I build this, we should now have an acknowledgements section. Now the one thing you will notice here is that the abstract environment changes the way the text formatting and styling works for the heading abstract. So if we want it to match our acknowledgement section, we'll actually need to redefine its definition. And the other thing I'm going to do here, just to keep our syntax consistent, is I'm going to create a new environment for the acknowledgement section as well. So we'll start with the abstract. So if I come back up to where we're creating our custom environments in the preamble, I'll modify the abstract existing environment so that it matches the style and formatting of the other two sections, the acknowledgement section and the declaration section. And we can do that using the renew environment command, and I can renew the existing environment called abstract, and then I must give it a beginning definition as well as an ending definition. And for our beginning definition, what I'll put here is the new page command to ensure we start on a new page, followed by the section command with an asterisk to add an unnumbered section, and the section will be titled with the command abstract name, which is an inbuilt command in LaTeX, which just prints the text abstract. And then for our end definition, I can just leave this blank. So if I rebuild this one, it should change the way the heading of the abstract is formatted, as you can see. So it is just more consistent with the declaration and the acknowledgements section. And the other thing that I'll do here is I will create a custom acknowledgements environment. And again, here I'll use the command new environment, and we'll call it acknowledgement. And it is going to have a very similar beginning and end definition to abstract. So I'll just copy this part and paste it below. And instead of titling it with the abstract name command, I'll title it acknowledgements. Okay, and the reason I've done that is just to, instead of creating our acknowledgements with the section and new page command, I can instead now use begin acknowledgement and end acknowledgement, and I'm just going to move the previous content, which is just lipsum 4.6, into that environment. And if we build and view this, hopefully that has worked. So as a result, we still get our acknowledgement section. Now we have all three of those sections, and they're all styled and formatted in a similar manner. The next piece of content that I will add here will be the table of contents. So I will add that below the acknowledgement section. And to do that, it's as simple as adding the command table of contents. I can also add list of figures as well as list of tables. And then later on, as we add sections and figures and tables, they will all be added to these respective parts. If I build this for the moment, we haven't added any actual chapters or sections, numbered sections yet. So as a result, we get a blank table of contents, but it is headed contents. And a similar thing happens with list of figures. There are no figures yet, so it's blank. They will be automatically added as we go, same for a list of tables. Now, before getting started adding chapters to this, or filler text for chapters, I will add a nomenclature section. So suppose if you had a thesis and it was going to have a lot of maths in it, and as a result you're going to have a lot of different math variables, it might be useful to add a nomenclature section, and it might also be wise to add that section in a way where it's easy to modify in the future the symbols that you use for different variables. So a possible way of going about this is if I come up to our preamble up here, and just below our title parameters, I'm going to create a section here for defining nomenclature variables. And all of these different variables are going to be math variables. And I'm going to create each of them with the new command. So I can use that new command. And for each of these variables, I'm going to start the name with the word math, and then I'll just use some name that makes sense. And then in the definition, I'm going to use a command ensure math and say this variable, I want it to represent time. So then I'm just going to use the symbol T. But the ensure math command will ensure that this definition is always written in math mode, whether you write it in normal text or actually in an environment. And as a result, I can use this command throughout all of the equations or in the text of our thesis. And if I ever in the future want to come back and instead of using the variable t, I want to use the variable tau, I can just change it here and it will change throughout our document. So that is why I am creating it this way. And I'll also here, I'm going to use a package called XSpace. And what that will do is it will add the correct amount of space after this math variable if needed. And I'm just going to repeat this process now for some other variables. So I'll use t for time. I'll also create one for velocity, and I'm going to denote velocity with a v, and I'll create another one for displacement, and this one I will use the letter x to denote displacement. And now that we have those definitions defined, I'm going to use them to create a nomenclature. So I'm going to come down here and I'll start by using the section command again with the star, and I'm just going to title this nomenclature. And then within this section, I'm going to house all of these variables and their description within a tabular environment. So I'll go begin tabular, and I'll create this tabular with two left-aligned columns to start us off, and I'll put in each of those variables. So the first one was math time, and then I'll just add a description. So I'll say time, and then I'll jump to a new row with a double backslash, and I'll just repeat this, math displacement for displacement. And the last one was math velocity for velocity. And let's build this and see how it looks. Okay, so now we have the beginning of a nomenclature. I'm just going to use the page break command before it, or I'll use the new page command actually to start us on a new page with this section. Now, of course, the handy thing about defining each of these mathematical variables as a command is that, because it's going to be very long, full of equations, you might be using t for time throughout. So you could have an equation down here, and the equation might be that displacement is equal to velocity times, so I'll use the times command for multiplication, times time. So now as a result here, when I'm writing my equation, I can use any of these commands, and if we build this, we get our equation, and maybe I could have another equation here using the same variables, and in this one I will write instead the kind of reverse of this, velocity is equal to the fraction of the displacement divided by the time. And again, I'm using those new commands which we created here. So now I'll have two equations in this little section, and they all have those variables. And we could also just test that these work correctly in some actual text. So below these I'll write where math velocity, which is that command we created, is the velocity. And I could repeat that for the other two variables. But the nice thing about these commands, because we have defined them with the ensure math command, is that they will work in math mode or outside of math mode. So when I build this, we get the correct expression. We get where v is the velocity, and it's written as a math variable in italic text. Same goes for in math mode here, it's written in italic text. And the nice thing as well here is we get the correct spacing. Space is added when we use this command in the text, and that is because of the X space command, which we used here in all of the definitions. And as well as this, in the future, you've written your entire thesis, you have populated with these particular variables that are used throughout. If now I want to come back and I decide I don't want to use X, the symbol X, to represent displacement, I can easily change it in this section of our preamble by just modifying the command. So we start off with displacement being represented by the symbol X, but now I decide I want it to instead be the symbol S. I can just change it and just build it once, and it's really easy to modify what variable we are using for each symbol. I could do the same with T. Instead of using T, I could use tau. Hopefully that will work. I might need the AMS math package for that one to work. Okay, so as a result, these variables will be really easy to modify in the future. So now that we've tested that those commands function appropriately, I'm just going to remove these sections and we'll come back to focusing here on the nomenclature. So I might change the styling of this a little bit to have horizontal dots to run from the variable to the description. In order to do that, I'm going to actually need to change this tabular to a tabular environment with fixed widths. And to do that, I must come back up here and also add the package array. So I'll use package array, and within that package, I can now use the column specifiers, which allow me to set a width. So I can use the specifier M and set a width 15% of the text width to create a narrow column, and I'll copy that and repeat it for our second column, and I'll make this a larger column. I'll say it spans 80% of the text width. And then what I'm going to do is to create a bunch of horizontal dots. I can use a command called dot fill, as you see here. So that should add some dots on our first line. As you can see, I've just lost the page. There we go. Now I want to have those dots on every single line. So instead of just adding it here into the content of the tabular environment, I can instead use the post column modifier. This letter M here is defining our first column, and after this I can put our post column modifier, which is the less than symbol, and two curly braces, and then here I'll put the dot fill command, which means that dot fill command will be placed at the end of each cell of our first column. So I'll go here, here, and here. So if I rebuild this, we should now have those dots on every line, as you can see. And now the last thing I might just change with this table is the spacing. So I can remove this dead space in the middle by renewing a length, and the length is called tab col sep. So it's this length here. I'm going to renew it to just be a shorter length. So I'm going to renew it to be 2 point. That will just shrink this distance, as you can see, or I might even go less. I might go 1 point. Okay, so normally that's the distance between two columns. And the other thing that I'm going to renew here is the vertical spacing. So to do that one, I renew the command array stretch, and I'm going to set it to 1.25. So that should vertically spread these out a little bit more. Perfect. So now I think that nomenclature is looking okay. I can actually turn this entire thing into a custom environment, again, just to tidy up the LaTeX code in our document environment. So I'm going to figure out here what is our beginning definition and our end definition, which of course are separated by the content. In this case, I want the content to be the actual content of the tabular environment, which is this part here. And as a result, all of this will be my beginning definition in a custom nomenclature environment. So I'm going to cut all of this, scroll back up to our preamble, and in our preamble, I'm just going to add another environment where we previously added the acknowledgement environment. So we'll create a custom nomenclature environment. And again, it's a similar process. We use the new environment command, and here I'm going to call this new environment nomenclature. And then I must give this a beginning definition as well as an ending definition. So our beginning definition I can paste in here, okay, which basically creates that section and starts the tabular environment. And for our end definition, it's literally just going to be end tabular. So I'll cut that, bring it up and paste it into the end definition. So as a result, we should now have this new nomenclature environment. So if I come back down, I should now have access to the commands begin, nomenclature, and end. And I just have to move the end to after the content, as you can see. And if I build this, it should build as normal unless we've made an error, which we haven't. Perfect. So now we have our nomenclature And we also have these commands which we can use throughout math equations in our thesis. Okay, and with that section added, we can now move on to adding the chapters of this thesis. So let's assume the first chapter is an introduction. So here I can use the chapter command. I might start this on a new page as well. And then I'm just going to populate this with some lorem ipsum filler text. So I'll go ipsum 1, 2, and I'll also just give it some sections. So I'll use the section command and I'll write the first section and I'll put some more filler text. I'll say ipsum 2 to 3, and I'll just add another section here, the second section. Okay, so that should now give us a placeholder for a first chapter. Okay, so this is now the introduction chapter. I'll just give it some more filler text in that latter section. Perfect, and I'm just going to copy and paste this to add the main content, and we'll also add below this a conclusion section. And if I rebuild this, we should now have all of those sections filled out. We'll come back later on to separate these into separate files. And if I scroll up to our table of contents, and we'll have to build this twice for the table of contents to populate, but you can see our table of contents has now started to populate. The final section which we will add here will be an appendix section. So I'm going to copy our previous code here for any of those sections, and I'll just paste down below an appendix section, and maybe our appendix section has just additional info. So I'll title this additional info, and of course if I build this, it will originally be named as chapter 4, but if I precede our appendix section with the command appendix, the appendix command will change how the chapters are numbered and titled, so this will now change to appendix A. And if I added a second chapter here, it would be appendix B, etc. Now, when we're done with this entire section, we will effectively finish with a full thesis template, which will have a example main.txt file full of lorem ipsum filler text and a document class file with all of the style and formatting. In order to just make that template a bit more comprehensive, I'm going to expand in the main content chapter and just add some figures and tables. So in order to add some figures, we're first going to have to open the project's working folder, which is this one here, academic thesis. So now we have our main.txt file and the other associated files. And in this file, I'm going to paste a fig folder. And in the fig folder, I just have some placeholder images. And each of them, 3 of them are portraits of famous scientists, and 1 is university logo. So later on, we'll add this one, the university logo, to the title. We'll come back to that one. The other 3 I'm just going to add into this section. So I will add a figure here to the main content section, just in the middle of it, and I'll add some more lorem ipsum filler text before it. So I'll use ipsum to 3, and this code I'm just going to paste as it's nothing particularly new. We use the figure environment to add a figure and the include graphics command with the width set to half the text width, and then we add an image from the folder fig, and then the image is named bower essentially, and then it's captioned and labeled, and it's just referenced from the text with the figure name and ref command, and the tilde symbol is used in between as a non-breaking space. So these are all things that we've covered in earlier sections. I am also going to have to add the package float for the capital H position specification. So I'll do that up in our preamble by using the use package float command. And if I rebuild this, we should now get an image. Oh, I forgot to add the graphics X package is what has happened. So I must also add the package graphics X so that we can use the include graphics command. Okay, so when we build that the second time, we now have our image, and it is also correctly referenced from the text. And if I come back down to that image, which is here, I'm just going to paste a second similar example below this one. So I'll paste it here. And again, this is just more similar code, begin figure, but this time I'm putting in the figure of the portrait of Albert Einstein. So if I build this, we should now get 2 figures. There we go. So we have the first one, Niels Bohr, and we have the second one, Albert Einstein. And if I build this one more time, it should update the list of figures to include both of those images. So now we have our list of figures, and you can see it's taking the text from the caption command, which is used in both of those figures to generate this list of figures. The last piece of code for adding figures I'll put here is going to be for adding subfigures. So as a result, if we want to add subfigures, we use the package caption as well as the package subcaption. And with those packages, I can scroll back down to where I want to place the subfigures. And I'm just going to paste the block of code that does this, because again, it's stuff that we've already covered. So we have our outer figure environment, and within that environment we can nest a subfigure environment, and for the subfigure environment we must pass a width. So I'm setting a width of 45% of the text width, which creates this block, this floating object in our output where a figure can be put. And then we use the include graphics command to actually put that figure. And then we'll give it a caption and a label. The label naming I change here to subfig : for the subfigures as opposed to fig : for the figures, just so they're easier to find when you use the ref commands. And then if we want to reference this from the text, we use the commands figure name and then tilde, and then the ref command to reference the overall figure, followed by its unique label generated in the label command. Or if you want to reference an individual subfigure, you use the same commands, but instead you pass the subfig label. So I'm naming the subfig labels with subfig : and the figure labels with fig : so it's easy to find them, because if you use the ref command in the suggested list, you'll get all of the label names essentially pop up: Fig Bohr, Fig Einstein, Fig Scientists. So then it gets easy to find, when you're creating a thesis, which could have 10, 20, 100 figures maybe. So if we now rebuild this, we should now have those subfigures. If I just scroll back down and find them, and there you can see we have our 2 subfigures. We could of course nest more subfigure environments. You could put 3 or 4 subfigures in the one overall figure environment if you wished. And you can also see this is figure 2.3, and it is referenced from the text as figure 2.3 or figure 2.3b using the ref command with the correct labels. Now, the other thing that we'll do here to make this example fully comprehensive is we'll add a table. So I'm going to add a table to section 2, and I'll start this section with a lorem ipsum filler paragraph just so that the table is surrounded by text. And here, if I wanted to add a table, we use the commands begin table and end table, and then I'm going to set the placement as capital H for place it exactly here. And then within this environment, I can use the centering command to center the table we are about to draw, and we can draw our table with the begin tabular and end tabular commands. And let's say I'm creating a really simple table with 3 center aligned columns, so I can go CCC, and then our content I'm just going to fill with numbers. So I'll say 1 and 2 and 3, and then I'll break to a new row, and I'll just copy and paste this a couple of times and modify it. So we have 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, and 12. Okay, so all of those numbers will now be the contents of our table. And then I'll also just add some horizontal lines before the table, and for the first row I'll add another horizontal line with the hline command, and I'll also add one at the end. So this will just be a placeholder for us to get the style and formatting we want for our tables throughout the document. And I'll also just add a caption as an example table, and we'll give it a label as well. So I'll label this as tab : example, and I'll also just reference it from the text as above. And then here I use the commands table name, which will just print the word table the same as it is in the caption. And then I use tilde as a non-breaking space, followed by the ref command to print the number of the table, and then I pass that the label. So the label here will be tab : example. So above in table 1 or table whatever, it'll be table 2.1. Above in table 2.1 is an example of a table, etc. So that is how you would reference the table from the text, very similar to how you reference a figure. So if we now build this, we should get a pretty simple table in our output. If I can find it, there it is. So this is our table. And of course, the default way that LaTeX prints tables, it could be styled or formatted a little bit better. Basically, it could be spaced better. So what we'll do here is we will modify this table so it just looks a bit better. So the first thing I can do is stretch it out vertically. And that is done by renewing the command array stretch. And I'm going to set it to 1.5. So that will stretch this out vertically. And another thing I could change here is the default thickness of these horizontal lines. And the thickness of those lines is set by a command, which you can see here, array rule width. So I'm going to cut this command and again nest it in a renew command, and this is an actual length, this one. So by default its value is 0.4 point, so 0.4 point is its default. I can change this to 0.8, which effectively should double the thickness of these lines. So now we have a table with thicker lines, and it just looks aesthetically a bit better. The last thing I will do to this table is I'm going to add a package called xcolor, and I will set an option called table. And this package allows me to change the cell colors. And there's one quite useful command here called row colors with an S. And how this command works is I say I want the row colors to start alternating on row 1. So I put number 1 in the first argument. And I want the odd row colors to be white and the even row colors to be a light shade of gray. So I can put gray exclamation mark 10, and that will be 10% gray, 90% white, and as a result we should get alternating row colors in our output, as you can see. So that can help the reader distinguish between the different lines in a larger table. And another thing that we can do here is we can create a new command, and I'm going to call this command head, and I'll use it to set the text formatting and style of the first row. So I will style these cells to have a darker gray color. So I'll use gray exclamation mark 50. So that'll be a color 50% gray, 50% white. And I'll use the BF series command as well. And as a result, everywhere I put this command head, so I'll copy it and just paste it into all of the heading cells. And all of these heading cells will now have those commands applied to them. So as a result, our heading should change to bold text with a darker gray background, as you can see. Now, imagine you could be writing a thesis that has a bunch of different tables, and you would like this formatting to be applied, but you don't want to be every time repeating this whole block of LaTeX code every time you draw a table. So instead, what I'm going to do here is I'm going to create an environment that will basically nest all of this style and formatting stuff inside. And I'm going to call that environment my tabular. So as a result, instead of using the tabular environment when I'm drawing a table, I will use my tabular, which contains the style and formatting I want, again, in order to just simplify the amount of LaTeX I have to write in the main.tex file. So to do this, I must figure out what is the beginning definition and end definition of this environment. And again, these are separated by the content. And I want the content to work the same as the tabular environment. So as a result, this will be my content, and this will be my beginning definition. And I'll keep the centering command, actually, it'll just make life easier. And our end definition will just be tabular. So then I will keep the caption and label outside this custom environment we create. So as a result, I'm going to take this code, copy it, come back up again to our preamble, up the top, and here where we've created these custom environments, one for acknowledgement, the last one was the nomenclature, I'm going to create another custom environment called my tabular. And the desired syntax I want for this is I want it to be begin tabular, it'll be begin my tabular. And then I also want to be able to pass this environment the column spec the same way you normally do for tabular environments. So here, what we want is the column spec. So as a result, this environment is going to take one argument. So we have to work that into the definition. And to create this environment, I can use the same command we've used previously, which is new environment, but I must use it with this syntax where it's environment name, and then you pass the number of arguments because we have an argument here. So it's going to be called my tabular. It's going to take one argument. So here I put 1, and then I must add the beginning definition as well as the end definition inside these two blocks. So in the first block, I'm just going to paste that code, but I must also modify this to pass the column spec argument. And I must be a little bit careful as well here with the new command, because if that is called twice, it will throw an error. So the correct way of me doing this is I shouldn't call new command in here, because when you create your first tabular environment, that will work fine. But when you create the second one, the new command will be called again and you get an error. So instead here, I'm just going to cut this out and I'm going to put it up before our custom environment. So I'll just paste it here. That should be fine. So as a result, this command will just be defined once in the preamble. It won't be redefined every time. And then the other thing I must change with this definition is how it handles the column specification. So the column specification is going to be passed as an argument. That argument I want to then pass to the tabular environment. So instead of putting CCC here, I should put #1 for put the column spec here, basically. And then our end definition should be really simple. It should just be end tabular. Okay, perfect. So now we have this new block of LaTeX code that defines this environment, my tabular, and we can use this for all of our tabular environments. And if you ever come back after you've written your thesis and you have like 10 tables and you want to easily change the default style and formatting, all you do is modify this one single environment instead of having to modify every table. So it's much more maintainable as a result of this approach. So let's now scroll back down to where we're actually drawing this table, which was down here. And now I can greatly simplify all of this LaTeX code. So I don't have to put any of these style and formatting here anymore. I can instead just start off with begin my tabular. I can use the same column spec or any other column spec, and I must end it with end my tabular, and I'll just delete the dead space here as well. And as a result, again here, our LaTeX code in the document environment again is just focused on the content. So if we build this, I should get the same output, except for the centering command has failed. I think the issue is just the fact that I'm using the centering command, which might not be working with when it's nested in the definition itself. So I'll just remove the centering from this command altogether, and I will then put the centering command back in here. So that might actually make this my tabular environment more adaptable, because then you can choose if you want to center it or not within the table environment, which is how you normally use tabular anyway. So I'll leave it as that, more straightforward. And then what I'm going to do below this table is I'm just going to add a second example of similar code. So I've pasted there this code, which is just a second table, and the contents are a little bit different. So as a result, we should now get a second table in this example. We have table 2.1, and now we have as well table 2.2. You can just see it's a little bit longer, but again, it's drawn with the my tabular environment. And then we just have to put the content into that environment, and my tabular is handling the styling and formatting. And we can easily as well change the column spec here. If I wanted the first column to be left aligned, I could use L, and that will change this to left aligned text. Or if I wanted to control the width of these columns, I could use the M column specifier and maybe set a fixed width of 1 centimeter, and then I'll get a 1 centimeter width in this first column, and we get left aligned text. And I could also maybe center align that text with the pre-column modifier and the centering command. And I probably have to use array, or no, I won't have to use the array backslash command. But if you did this in the end column specifier, you'd have to use array backslash within the pre-column modifier as well. So now we get center aligned text in our table and fixed width. So the my tabular environment is just as flexible with the column specification as the normal tabular environment, essentially. And with that table added, our list of tables should now be updated with those two tables. So if I scroll all of the way up, we can see we have our list of tables, and we have table 2.1 and 2.2, and it takes the text from the captions. So now we're getting closer to a completed thesis. You can see we have all of our different sections and our title page. The next thing we'll move on to in the next lesson will be the bibliography section. So then we'll have a full thesis with all of the content, and then we can move on to customizing all of the style and formatting. So I will leave this lesson here, and I will see you in the next. Next up, in this lesson, we are going to look at adding a bibliography section. And in order to do this, we're going to have to create a bibliography. And to create a bibliography, what we do is we create a group of bibliography entries. And there are different types of entries that you can have. So the more common entries you can use are book, article, PhD thesis, and tech report. And to create the bibliography, we are going to create a .bib file, and then within this .bib file, we define each of these entries. As you can see here, we have an example of a book entry, and an example of a tech report entry, an example of an article entry, and an example of a PhD thesis entry. And of course, in this .bib file, you can have multiple entries of the same entry type. Each of the entry types starts with the @ symbol. That's what you have, @ tech report or @ article. And then how you define each of these is the entry type name, which here is tech report, is followed by 2 curly braces, an opening one and a closing one. And then you have all of these comma separated entries. The first comma separated entry is a unique key, and normally you start these off with bib : and then what I prefer to do is name them with the author surname, the year of publication, and some keyword that helps me remember what the article is, or in this case a tech report, because sometimes you can have 2 entries and they were published the same year with the same author surname, and then an extra keyword I just find helps when giving these entries a unique key. So the first one is the unique key. We'll use that later as well to cite the entry in our main.tech file. And then you can see after this, we basically have a list of comma separated keywords. So the keywords here are title, author, year, and institution. And then each keyword gets an associated value, which is defined again in two curly braces. And so our tech report here is effectively defined by a title, its value, an author, its value, a year, its value, an institution, etc. And then for our other entries, such as article, you effectively will have a different list or a slightly different list of keywords. So in this case, for article, we have title, author, and then going down, journal, volume, number, pages, year, etc. You can, if you wish, say you might be trying to reference an article, but in that article there is no volume to describe it, or there is no number, and then you can just leave one of these completely blank. You don't enter any information for volume, and then that information won't be published to the output bibliography. So effectively what this file up here is doing, references.bib, is defining all of the values of each bibliography entry. If we then want to cite any of these references in our main.txt file, we use LaTeX code as is seen here. So you can use a command called cite, and then you pass the command cite the unique key which you defined for any given reference in your references.bib file. So you can see here, if we want to cite this article, it has a unique key called Bib Johnson 2018 VLSI. And then if I want to cite that, I simply pass that unique key to our cite command. And as a result, in our LaTeX output, we should get something like this. You can see here we have the text, this is discussed further in cite bib, so on and so forth. And in our output, we get this is discussed further in, and it is just down as citation number 2. And then if we want to actually print our bibliography in our main.txt file, there's two commands we have to use. So the first is bibliography style, and then you set a style such as plain, or this one here is unsorted. There's an IEEE transaction style. There's one called alpha as well. So we set the style, which will determine the formatting and style applied to the bibliography. And then we use this command here, bibliography, and we pass it the name of our actual .bib file. This command will print in the bibliography any articles which have been cited throughout our main.txt file using that cite command. And if we were to build this code, we should get a bibliography section in our output. And you can see there, when we used the cite command, we had reference number 2, which was this article Johnson 2018. And then you can see here, if we look at the second entry in this bibliography, it is written by this author, Johnson, in the year 2018. So that is the same one as was defined previously in our references.bib file. And then each of the values here of author or the title, this part is the title, or this part here is the journal. And then you had stuff like volume and pages, whatnot, and then the year. So those are all the values of the different keywords that we previously used back in the references.bib file. Now, this current output of this bibliography is printed using the plain style, but if we were to change that style, the way that it is printed and displayed and what the cite command would also display would change. So if we were to change it, instead of using plain, but instead use alpha, then as a result, what happens is the way the citations are tagged, instead of it being numbers, it is now done with the author's surname. As a result, here you get and, short for Anderson, and then the last 2 digits of the year. So you get 19, which is corresponding to 2019. And then the next one, the third one down. So we'll also change the order. So now they're listed in the alphabetical order of the author surname. So it's Anderson first, then Johnson, and then Johnson again, etc., then Lee. So as a result, this reference here, Johnson 2018, is now defined by this reference. And you can see it is just printed differently in the bibliography. And it would also change here how it's printed in the cite command. Instead of getting 2, our cite command would now print JL18, and that style and formatting is being dictated by the bibliography style command and just using the alpha style instead. And there are different styles you can choose from. I've listed 4 of them here, but there are a couple more. So what we'll do now is we'll jump over to Text Studio and we'll look at adding this bibliography to our thesis. Okay, so here in Text Studio, the first thing I'm going to do is add a new file. So I'm going to hit Control N to open a new file, and we'll use this file as our references.bib file. Instead of manually typing out all of those bibliography entries, I'm just going to paste them here. So you can see each entry starts with an @ and we have one for a book entry, one for an article, one for a PhD thesis, and one for a tech report. Each entry starts with the unique key name, and then they are defined by these list of comma-separated keywords, such as title, author, year, and their value, such as 2010, enclosed into curly braces. The easiest way to create your own references.bib file is basically use an existing file as a base. So you could use this file as a base, and if you wanted to add a second book, you can just copy this entry, paste it down below, and then just modify the values and give it a unique key. In order to be able to reference this from our main.txt file, I'll have to save it, and I'm going to save it here to the same folder as our main.txt file, and I will give it the name references.bib. So it's a .bib file, and now you can see that TextStudio recognizes the syntax and colors the bib LaTeX code or the bib syntax as a result. So you have the keywords are in this darker brown and their values are in red, and each entry type is in blue: at book, at article. With that file created, I can come back to my main.txt file, and if I want to add our bibliography, the first thing I must do is choose a style. And to do that, I use this command here, bibliography style, and if I hit comma, you can see the different options. So I'm just going to go with plain for the moment, and I'm going to remove that comma, and then below this, to actually add the bibliography, I can use the command bibliography, and then I pass it the name of our .bib file, which was references.bib. And then if I want to cite any of our references from our file, I just have to remember the key. Now, the easiest way to do this is just use a naming convention that's easy to remember which article or book refers to what key. So what I normally do is bib : author surname, the year, and some keyword. And then here in my main.txt file, if I wanted to cite a reference, I could say cite, or I could say C, and then I'll use the cite command, and I just pass it that key, which is in the references.bib file. So I'm going to cite here this one, Babe Smith 2010 digital. And if I build and view this, you can see in our output, we now get a bibliography at the end of our thesis. And we have entry number 1. And the entry is created with the values set for the different keywords. And if I come up to where I used the cite command, you can see here has C1. And basically the 1 in square brackets replaces that cite command. I can repeat this to cite the other bibliography entries. So I'll cite this one and the next one and the last entry there, I think it was this one, Lee. And if I rebuild this should grow our bibliography so that we now have 4 entries, because our bibliography will only be populated by the ones that we actually use with the cite command. So that has failed to actually work. Instead, I'm just getting the question marks. So if you get a bit of trouble with running with the bibliography updating itself, what it might be is that LaTeX can struggle to overwrite these files, the .bbl and the .ogs file. So if you delete those from the working folder, and then I will come back to our main.txt file and rebuild this, you can see the entries have now updated and the question marks are removed basically, and our bibliography is now populated with all of those entries which were defined in the .bib file. Now, you'll notice in this style plain that in our bibliography, they are numbered 1, 2, 3, 4. I think they go in the order of the alphabetical order of the first author's surname. So as a result, it's Anderson, then Johnson, then Lee, then Smith. But you'll notice that in the way that we cited these, as a result, number 4 now is given to the one which is written by this author Smith, because he just comes last alphabetically. If you don't like that behavior and you instead want your citations to work, whichever is cited first is number 1, then what you do is you don't use the plain style. Instead, you use this style here called UNSRT, short for unsorted. And if I rebuild this, that hasn't updated. So again, I have to go back to my working folder, delete these 2 files which LaTeX is struggling to overwrite, and then come back to the main.txt file, try build it a second time. Okay, and in this case now you can see that our citations are numbered in the order which they come in as we use the cite command. So you can see it goes C1 or 2 or 3 or 4, and our bibliography is renumbered accordingly. So in this case, the author here, Smith, or this entry, comes first because it was the first entry which we cited here in our code. And of course, as well as this, there are more entries. So I could as well switch to any of these, IEEE or Alpha, for instance. And as you change the style, just different formatting and a different way for how the citations are tagged, what code is used to tag them all, will change for the different styles. So for this one, I'm going to again just delete those 2 previous files to make sure that the new style is applied. And if I rebuild this, now the style alpha should be applied. And now as a result, you can see that these citations are actually tagged differently. They're no longer tagged by numbers. They're tagged by this Smith 10, Anderson 19, I forget what JL was, whatever this one is, JL, David Johnson 2018, etc. And of course, you can just continue changing this to whatever is the style of bibliography that you prefer. So I'm going to revert this to unsort because I think that works best. And then I will leave this lesson here and we will move on to the next lesson in this thesis, in creating this thesis. In this next lesson, we are going to take a look at how we can add a custom title page to our thesis. So far, we have used the commands such as title, author, and date to define the information within our thesis. They are all passed as arguments to those commands. And then in our document environment, we use the command make title, which takes all of that information of the title, author, and date and uses it to print a title to our document environment. Now, although this approach has very simple syntax, unfortunately, it's not very adaptable. So in this lesson, what we will look at is creating a custom title page so that we can change how the title page looks. And we will do stuff like add an image. You may want to add an image of your university logo to your thesis title page. So we will look at this, and then we will look at customizing how the title, author, and date are presented. And then we'll also look at just adding some more text to our actual thesis. And how we're going to do this is we are going to expand on these commands over here, which define the information in our thesis. We're going to add this command called university, which will define a university name, which we then add over into the actual title of our thesis. And this, of course, is a custom command, so we'll end up using the new command to create this command. And then as well as this, we're going to modify how our title page is printed, and to do that, we're going to use the environment called title page. You can see we have begin title page and end title page, and then we'll work through this LaTeX code which creates this custom title page output over here. So let's now jump over to Text Studio and let's go through this example. Okay, so here in Text Studio, we have our simple title page made using these commands, title, author, and date. I'm just going to move them down to just before the document environment so we can fit all this stuff just within the actual screen itself. And then the first thing I'm going to do here is I'm going to remove the make title command, which is currently creating our title page, and change it to the title page environment. And within the title page environment, I can print any of the information from these commands using the respective internal macros, which are then used to store this information. So we have this command here called title, and it takes this argument, this is my title, and it actually passes it to an internal macro from the report document class, and that internal macro is called \@title. So if I wanted to print the information in the title or the text of the title, I can use this internal macro \@title. But if I use an internal macro, I should wrap this LaTeX code within the commands make @letter and make @other, so that the symbol here can now actually be used in command names, and we can use internal macros such as this one. So if I build this, you can see our title page is replaced just with the text, this is my title, defined from that command title. I can also add to our title the author, which is defined in the internal macro \@author, and I'll add a double backslash to jump to a new line, and I'll also add the date. So the date is stored in this command \@date. And if I build this, you can see that information is also added to our title page. Now, you might be wondering why even use this title page environment? Why not just put this in a center environment? The nice thing about the title page environment is it will force this information onto a new page. So this is all on its own page. And it will also remove the page numbering, which you need to be removed from the title page. So there's no page numbering down here. And the next page where we have our declaration starts on page number 1. So it just adds those couple of commands that controls that, so we don't have to. Now the next thing that I'll do here is I'll add a center environment to center all of this information. So I'll use begin center and end center around this information, and that should move this text to the center, as you can see. And the next thing I'll do is I'll just space this out a little bit better. So instead of using the double backslash, I'm going to use double backslash followed by 2 square brackets, and then I can put a custom length in here, and that custom length should space this text out a bit further. So I should now get a 1 centimeter gap from the first line to the next line down, and then I'll repeat that and I'll add a 0.5 centimeter gap below, and I'll rebuild this. So now that should all be vertically more spread out. And the next thing I'll do is I'm just going to change the text formatting of our title. So to do that, I can use the command BF series to make it bold, and the command large to make that text large. And I'm just going to enclose all of that in a block or within 2 curly braces so that those commands are only applied to the text of the title, as you can see. So now we have something that kind of resembles how the make title command used to work. We can now expand on this and do something like add a university logo. So if I wanted to add a university logo to this, I use the command include graphics, and I must pass the image path of the file in which our university logo is stored. And that file is, I have it in the same working folder of the project, and then within that there's a folder called Fig, and then within that there is a PNG image called university logo. So I can add that image here by typing out the image path, which is fig/university logo, and I don't need to add the .png part. And now I'm going to control the size of this image by setting a height equal to 10% of the text height. So that should add a university logo image. Now, of course, what I forgot to do there is add a double backslash to put this above the title. So I'll add a double backslash, and I'll also put 2 square brackets and the length 1 centimeter to space it out from the text of the title. So now we have all of these vertically one after the other. Now, as well as the title, author, and date text, you may wish to add some more information to your title. So we have these 3 commands, title, author, date, and we will try and keep the syntax quite similar. So we could create a new command here to store the name of our university. And that command could be university, and then it would take an argument, and that argument would be the text or the name of the university. This, of course, isn't an inbuilt or a default command in the report document class, so we would have to create it as a new command. So I'll just create it as a new command a little bit more higher up in our preamble. I'll add a comment, create a new command to define the university name, and the syntax of that command is going to be university text. And the way this will work is we'll pass it an argument, and then it will create another command that actually stores the name. So effectively, we will create a new command to define the university name in a command called university name. And how we do this is we use the new command, and we have it take 1 argument, because we have 1 argument here. The name of this command is going to be university, and its definition, we will define it as the new command again. So we nest the new command inside itself. And basically, if the command university, this command here, if that command is called, create another command, which is going to be called university name, and it will be defined by the text which we pass to this command. So as a result, I put #1 here for the university name will be defined by the first argument. And effectively how this will work is very similar to all these commands. So as a result, I can now use this command called university, pass it some text. I'll say the university is called Innoved Academy. And as a result, I should now be able to use this command up here, university name, in the LaTeX code which defines our title. So I could add a line below the author, let's say, and I could say a thesis presented by, and then here I'll just paste the command university name, and I'll add the same double backslash and a 0.5 centimeter gap. And now we should get that line of text printed to our title if I haven't misspelled something. So I think what I've done is I've misspelled university in this definition. So I'll just correct that and try to rebuild this. And now you can see we get that line of text is added to our title, a thesis presented by Innoved Academy. And using a similar procedure, you can create other commands just like this and then add them to the actual title page. And of course, we do it this way so that later on we can create our own custom thesis document class that will have this command inside it. So you would just need to add the document class thesis and then use these commands to define your title And then here I can even simplify the document environment LaTeX code more by, instead of having this block, I can actually renew the make title command to be defined by this block. But if I do that, I should actually change the way make title works, because here we're passing the image path of our logo to this block of text basically. So I could redefine make title to take this as an argument, and that would keep our syntax very simple. So in order to do that, what I shall do is I shall cut this, and what I want to replace it with is the command make title, but I'm going to redefine make title to take an argument, which is going to be the logo path. And in order to do that, what I'll do is I'll just add another custom definition, and I'll add a comment to explain it. So here I'll put renew the make title command as make title, but it will take the argument of the logo images path, and then it will print that logo to the actual output. So if I want to renew the command make title, I can use the renew command, and the command I want to renew is make title. I want to redefine this command so that it takes one argument, the logo path. So here I put 1, and then here I can put the definition. So I'm just going to break that to a new line, and I'm going to paste our previous code which defined the title. Now, the other thing I should do when I do this is I should move the make at letter and make out other just outside the actual renew command. Otherwise, the renew command might throw an error. So now they're outside. And the next thing I should do is, instead of using Fig University logo in the definition, instead that is now defined by the argument. So as a result, this is now our new definition of the make title command. And when I come down here to my document environment, instead of having to type out all of that code, I can just use the make title command and enter in the image path of our logo. And hopefully, if I haven't made any mistakes, this should rebuild as it is. So there we have it. Now we have our custom make title command with our additional info and our university logo. I will leave this lesson here, and I will see you in the next one. In this next lesson, we will look at separating out our current pretty lengthy main.txt file into separate files. So we will split our main.txt file into other text files, each containing the content of the respective chapters or the appendix. And we will do this using the include command. So you can see the syntax is pretty simple. It just takes the argument of the respective file name. And the other thing we'll do in this lesson is we will split up our project a bit further by separating out the main content from the style and formatting, which we will contain in a custom My Thesis class file. So as a result, we will also create a custom document class file here, the My Thesis.class file, which will contain the style and formatting of our thesis. So all the previous custom commands and custom environments we will basically put in here. And as a result, everything to the left-hand side here, all of our .text files can now be more focused on the actual content. So it'll make all of these files more simple, basically, and it will also make them all easier to maintain. It'll be much easier to make changes regarding the style and formatting in the future if we split them and keep them separate. So let's now jump over to Text Studio. And here in Text Studio, we can start by splitting out our different chapters. So if I come down to where we have defined our chapters, say we have our first chapter here, the introduction chapter, and I can take all of this, I will just cut it, and I want to replace it with the command include, and then a new text file, which I'll call chapter1.text. And then of course, we'll have to create a new file, which will be the chapter 1. So this is going to be chapter 1, and then I just save it to the same folder as our main.text file. So this will be chapter1.text, and I'll just hit save on that. So now we have two separate files, and I'll just jump back to our main file and I'll rebuild it just to check that that has actually worked. So you can see we still have chapter 1, and I can basically just repeat this process then for chapter 2. I'll just add the include chapter 2 command, and our actual LaTeX code for chapter 2 is all of this stuff here. But chapter 2 is actually pretty lengthy because we put some figures and tables in there. So it's all the way down here. So I'll just cut that, and then I want to create a new file. So I'll hit Control N, and then I'll paste all of our chapter 2 LaTeX code in here. Chapter 2 was the main content chapter. Save it as chapter2.text. Hit save, come back to the main file, and now we should have chapter 2. And I'll repeat this for chapter 3. So I'll say include and I want to create a new file called chapter3.tech, and I want our chapter3.tech file to contain all of this LaTeX code, so I'll just cut that and then hit Control N for a new file, hit Control V to paste it, Control S to save it, and save it to the same folder as chapter3.tech, and I'll just hit save, and I'll just close chapter 1 and 2, and as well I will do it for the appendix. So the appendix, I'll add a command called include, and then we must put the file, so I'm going to create a file called appendix.tech, and I want the appendix.tech file to basically take all of this code here. So I might move the bibliography up as well. I'll put it before the appendix, so the bibliography will now be after our 3 chapters, and then we have the appendix section, and this is the LaTeX code of our appendix. So I'll just cut that code and then create a new file, paste that code there, save it as appendix.tech, and then I'll save that. And if I come back to our main.tech file, hopefully this still rebuilds. Yep, and we have our different chapters. So there's chapter 3 was conclusions. Chapter 2, we put some tables and figures. And then after these main chapters, we have our bibliography. And then after this, we have our appendix. And our main.tech file has now become much simpler. So I might just delete some of the dead space in it so we can actually see how simple it has become. I might actually move this LaTeX code as well just to the chapter 3. I'll put it down here where we were verifying the cite command works, and then I'll just get rid of some more of the dead space. Okay, so now you can see how simple our main.tech file is. Our document environment is just in this block, and we're making our title, adding our declaration, adding our abstract, the acknowledgements, those list of figures, list of tables, table of contents, the nomenclature, and then our different chapters and the bibliography. So as a result, the main.tech file now becomes this very readable high-level file. But of course, if I scroll back up here, our preamble is quite lengthy. Say if I go from this point up, our preamble is quite long because we've added a lot of custom environments and we're using all of these different packages. And I could simplify our preamble by moving a lot of this stuff to a custom document class. So to create a new document class file, I'll hit Control N, and I'm going to save this as my thesis.cls, and I'll hit save. And a document class file is normally broken into 4 parts. So we'll have the identification, then we'll have preliminary declarations, then you normally do the options handling, and then after this you have more declarations. So we'll start off with the identification section. There's 2 commands you always have to add here. They are needs tech format, which is LaTeX 2E, and the other one is provides class. And here we give our class a name, which should be the same as the file, so it'll be my thesis. And then for the release info, normally you just put the date. So today is the 23rd of the 7th, 2025, and I put down here just some info that summarizes what this document class will do. So it'll be my custom thesis class for how I would like my custom thesis to be styled. Then after this, how this file always looks, I'm just going to close some of these extra files here. We don't need any of those for the moment. So our main.tech file, we normally in the start of our preamble, we use the document class command, and then we use all of these packages. So I'm just going to copy that chunk of code and I'm going to paste it in here. But instead of using the document class command in the actual document class file itself, you should instead use a command called load class. And that's load class with a capital L and a capital C. So if I started typing load class, you'd see it come up there. So that's the load class command. So instead I go load class report, so that my thesis class will inherit all of the LaTeX code from the report.cls file, which is locally stored somewhere on your own computer, and LaTeX will know where to find it. And then instead of using use package, I should use the require package for any packages that we will use. So I'm only going to actually need the packages that are used in any of our custom environment definitions or any of our custom command definitions. So some I won't need. So the Ellipsum one I don't need. Xspace we are probably using somewhere in our custom commands. So here I'll put require package, and then I will repeat that for the other packages. So I'm just going to require them all. And as a result, even though our other 2 sections are blank, this should be enough to define a class file. So if I come back to our main.tech file, I should be able to remove all of those packages because they'll now just be in our my thesis document class. And now instead of using the report document class, I can put my thesis. And hopefully if I rebuild this, it should build okay. Okay, perfect. That is still built as normal. And now I can simplify our preamble here, because all of these custom environments, our renewed abstract environment, and what else do we have? Our custom acknowledgements environment and the nomenclature environment. And we had a custom table called my tabular, and we had this university command, and we redefined the make title command all the way down to there. I'm going to cut all that, which are just our custom environments and our custom commands. The other stuff here is going to be specific to this thesis. So the only stuff I want to move to the my thesis document class are stuff that I would reuse in another thesis with the same style and formatting. These commands are specific to the actual content of this thesis, and so are these commands down here, because you could use the same my thesis.class file, but maybe it has a different author or a different title, or a different university, etc. So that stuff I will leave here. The preamble of this file is still a good place for that code, but all of those custom commands, I'm going to come in here and paste them into the more declarations part and hit save. And if I come back to our main.tex file, which is now much shorter and again much more readable, which will make it much easier to modify in the future, is now much more simplified and tidy. As you can see, our preamble is short and our document environment is short. So I will leave this lesson here and I will see you in the next. In this next lesson, we're going to look at how we can add further customization to our thesis. And the extra bits that we're going to customize are listed here. So we'll start by customizing the fonts and also customizing how the section titles are formatted. That's how the chapter and sections are formatted. And then we'll also look at how we can customize the page layouts in the front matter and the main matter, and we'll create custom commands to do this. We'll also look at how we can easily create a correctable version of our thesis, and we'll actually add that as an option in the document class command, so that we can write document class correctable my thesis to get the correctable version. And we'll also look at what is the right setup for generating a two-sided printed version of our thesis and a one-sided printed version, as well as an online version, because you'll generate different PDFs for these. Will change different things like the page layout, because if you're getting it printed either one-sided or two-sided, you need to change the page margins to suit the binding. But the first thing here we'll look at is, of course, custom fonts and title formatting. And what we'll end up doing here is we're going to start with the version on the left, which is the default setup. And you can see chapters are titled like this. You have the text chapter 2 here, and then you get a bit of a break, and then the main content is in very large font. And then as well, this is the default way that the sections are, how the text is formatted in the title. And what we will change this to over here is this version, where we get bold, small capital, and it's all on the one line. And a similar thing down below. We'll just change the text formatting to bold and small capital, and we're also changing the fonts. And the way we'll do this is we'll use this code that you can see here. And this code, instead of adding it to our preamble, we're going to keep the main.tex file simple, and we'll instead add it to the mythesis.class file. And in our document class file, instead of using the use package command to add external packages, we instead use the require package command. So here we can require the package new text mat and new text, which will change our font to a Times-like font, both for the mat that we write and also the text that we write. We'll also set the page size up as A4 paper with the geometry package. In Europe, theses are more commonly written on A4 paper, but in the US or Canada, letter paper might be the more standard size. We'll also use this package here called TitleSec, which will give us access to this title format command, which we can use to either customize the way our chapter titles text is formatted, or the way our sections title text is formatted. So let's now jump over to Text Studio and make these changes. Okay, so back in Text Studio, I'm going to jump over to our document class file, and then here just below where we've added the other packages, I'm going to paste that code we showed there. So it is require package, new text, and new text, which are comma separated, changing the paper size to A4 paper with the geometry package, and then I can use the title package as well with these commands. There's two variations here. So there's title format without a star, And you can see the way that this is set up. We have to specify the command we want to change. So it'll be chapter. So if I scroll down to one of our chapters, you can see we have chapter 1. So as a result, the following formatting will be applied to all of the chapters. Then we specify the format. And here we just put the font commands, which we want applied to our chapter. So we're going to change this to bold, small capital, large text, as opposed to the current. And then the label is basically this part here where it reads chapter 1. So we'll actually keep that part the same because it'll be chapter 1, tilde is a non-breaking space, and then the chapter command prints the number 1 or just the number of the current chapter. And now the thing that will change here is the separation. So currently the separation breaks to a new line. We're going to change the separation just to a length of 1ex. So now this will all be on the one line, and the text chapter 1 will be separated from the introduction by one line. As well as changing the chapter title formatting, we'll also change the section title formatting. But here I'm using the more simple command of title format with a star. And in this case, we just set the command we want to change, which is \section. Here we define what formatting, what text formatting we want applied. So if I come down, you can see currently it's probably bold, large text. And now it will change to bold because of BF series, small capital because of SC shape, and it will stay as large. So changing that formatting is as simple as adding those commands to the document class file or whatever other formatting you wish to change. Then I can just come back to my main.tex file and build this, and we should now see the formatting applied to our main.tex file. So there you can see we now have the font has changed to Times New Roman font, and both the matte font and the text font will have changed here. And then you can see our chapter and our section titles are formatted different as defined in those commands. The next thing that we will look at customizing will be how we have set up things like the page margins and the page numbering for the front matter as well as the main matter. And to do this, we're going to create two custom commands, one called main matter, one called front matter. And these are going to work a little bit similar to how the appendix command works, where you place these commands at the start of the relevant section, and it will just control certain things. So if I come back to our main.tex file and I scroll down to our appendix, and it's actually probably in the appendix.tex file, we use this command appendix, and when we run that command, it basically redefines certain things so that our chapters now appear as an appendix normally would. So as you can see, what that command is actually doing is it is resetting the chapter counter to 1, and then it is redefining the command that chapter to not print the chapter in Arabic numerals 1, 2, 3, but instead print the chapter, that command, in capital alphabetic numerals. So now we get chapter A, and then we get section A.1, and if we added another chapter, we would get chapter B, as that is how appendices are typically numbered. Now, similarly to how you want to change the style and formatting of an appendix section, we also want to apply slightly different formatting to our front matter and our main matter. And this is commonly done just in books or in printed works, and of course it's also commonly done in theses. So if I come up to the start of our document here, anything between the title page and the actual content, so everything we have here, the declaration, the abstract, the acknowledgements, the tables of contents, list of figures, list of tables, that is all of the front matter of our thesis. And typically what you would do then on the front matter, you would set your page margins up to be slightly wider on the left, right, top, and bottom, as opposed to when we get down to our main matter, which is here, which is all of the contents, you would then set up your page margins to be more narrow. Now, the other thing that is commonly done is the page numbering of the front matter might be different to the main matter. So we will change our front matter, such as here, nomenclature and the other bits, to Roman numerals. And then when we get to the main matter here in chapter 1, we will reset the page counter so that the page counter here goes back to number 1. And we will build this functionality into two commands. So those commands are going to be front matter, which I can just place where the front matter starts, and then I would place another command called main matter where the main matter starts. And these commands are not defined by default in the report document class. They are in fact default commands in the book document class. And since we've used the report document class as the kind of base class of the my thesis class, which is the one we're using, these commands aren't defined, and so if I try and build this, it should throw me a bunch of errors, as you can see, because these commands are not defined. We get an undefined control sequence. So what we'll do now is I'm going to come to my thesis.class file, and I'm just going to add some definitions for these commands. So I'll do it here in the more declarations part. I'll say define the front matter command, and then I'll copy that, and just below it we will define the main matter command. And to create this command, I'm going to use the new command. It's going to be called front matter, and then in our definition, what I want to do here is start our front matter on a new page. So I could use the new page command. An alternative I could do here, which is more wise, is to use the clear double page command. Now the reason that I'm doing this is because I'm also going to reset the page counter. And to do that, I'm going to use the set counter command, and there's an inbuilt counter in LaTeX called page, which stores the number of the current page. And I'm going to reset this to 1. And the reason why I want to use clear double page before that is it will force everything before the front matter to be printed to the PDF output, and it will also ensure that when we start a new page, it is on an odd numbered page, and that's actually needed to get the two-sided printing correct. So if I reset the page counter to an odd number, basically I should use the clear double page command before it. And I also want to redefine our page numbering to be in lowercase Roman numerals. And to do that, I'm going to use the renew command, and I want to renew the command the page, which is responsible for printing the actual page number. And by default, this is defined as Arabic, and then it prints the Arabic value of the counter page. So I pass the counter as an argument to that command. But instead of using the Arabic definition here, I want to use Roman for lowercase Roman numerals, and that should reset the way that the page numbering is being handled. The other thing that I'll do here is I'm going to set up our page margins. And in order to do that, we need to use the geometry package, which we actually already have. And then if I want to control the page margins here, instead of setting them as an option, because you could set all this stuff as an option in the require package geometry command, instead I'm going to use a command new geometry, and then here I can just set the options as I would in the options of the geometry package. And those options are going to be as follows. I'm going to set the margins as left and right are 4 centimeters, top and bottom are 5 centimeters. So these are going to be some pretty wide margins. And now what I'm going to do is I'm going to copy our new command and create a similar command for the main matter. But what's going to be different here, I'm also going to reset the page counter, but I want it to be in Arabic numerals. So I'm going to put down Arabic. So that'll be the numbers 1, 2, and 3. And then I'm just going to make our margins more narrow. So instead of using 4, I'll use 2.5 centimeters for the left and the right. And for our top and bottom, I'm going to use 3 centimeters. So if I now come back to our main.tex file, we already have our front matter and our back matter. Sorry, not our back matter, our main matter commands. And if I build this, they should now be applied. So we should see here on chapter 1, front matter is already defined. Oh, sorry, I'm after forgetting to change the name. So this was meant to be the main matter command. So now we have our definition for the front matter and our definition for the main matter. So if I now come back, if I save this and I come back to our main.tex file and rebuild it, it should now run, and that has now run successfully. And we can see here, this is our main matter. So when we get to the main matter, what we want is the page counter to reset. So this is now page number 1, followed by page number 2. You can also see we now have narrower page margins because that is what we applied to the front matter command. And in our back matter, our page numbering is in Roman numerals. And here as well, we should have wider page margins. Okay, now the one thing to note with how we have this currently set up is in our current version, the left margin and the right margin are the same size. And that, of course, is fine if this PDF was the online version of our thesis. But if we were getting our thesis printed, we need to set up our page margins a little bit different to allow for the actual binding. For example, I have this refill pad here, and as you can see, on this edge, we have the binding, but you can see the binding takes up a little bit of space. So on your thesis, wherever you're getting it bound, you need to ensure that that edge of the page has a wider margin for the actual binding itself. And if you're getting your thesis printed one-sided, then that would mean that it will be the left margin that's always a bit wider, versus if you were getting a two-sided printing, then it would basically be alternating left, right, left, right. So we haven't set that up yet, but we will set that up in a future lesson. Now, the next thing that we will take a look at here is how we can create a correctable version of our thesis. And in order to do that, we're going to add some code, as you can see here. Now, when I say correctable version, all I mean is that we alter the line spacing. So normally theses are written in 1.5 spacing, but if you're creating a correctable version, normally you actually increase the line spacing to double spacing, and then you print it off, and then it's easy for someone to write corrections in between the lines. Or as well, you could just do that in a online PDF version on a computer, and it's easier for someone to add in text between the lines where there might be corrections needed. And the other thing that we'll do is we're going to add line numbering up the left hand side, so it's easy for someone who is correcting it to point out in chapter 2 on line 9, you have made an error and it must be corrected, etc. And the other thing we'll do with this is we'll set these numbers up so that they are reset every chapter. And in order to do this, we're going to use two packages. So we're going to add this code to our My Thesis document class. We will use the packages setSpace to control the line spacing, and we will use the package line_no to add these line numbers, and that will give us access to the commands you see here. Set stretch to a certain factor. If I use set stretch 1.5, it will change our line spacing to 1.5. The command line numbers is from the line_no package, and it basically turns on the line numbering. And then we also can renew a command called line number font, which controls the font text formatting of the line numbers. So you can see here they're small and bold, therefore we get small bold numbers on the left. Now, the other thing that would be useful with this, because sometimes you will want to output your thesis as a correctable version and sometimes you don't, we could set this up as an option. And this, of course, is possible by just adding some options handling code to our document class file. And what we'll end up doing is we'll create an option called correctable. And if that option is used in the document class command in the main.tex file, then we will basically get this correctable version of the line numbers and the different spacing. So let's now jump over to Text Studio. And here in Text Studio, to create the correctable version of our thesis, what I will do is I will come up to the top and I'm just going to add those two packages. And I've also pasted here, which were a setSpace and line_no, and I've also pasted here the code which will add those line numbers, and I'm using the setStretch command to change to double line spacing. And I'm just going to save this, and now when I rebuild it, this code of setStretch2, line numbers, and the changing the line number font should now be applied to our main.tex file. So we should see the line spacing increase, and we should get these numbers up the left hand side, as you can see. So we now have double line spacing and these line numbers. Now the issue with the way that we have done this is that the line numbers are incremented every line for every chapter. So you can see here chapter 1 starts on line number 79, and then chapter 2 it's an even greater number, and chapter 3 is on line 215. So of course, if you're writing a thesis, it can be quite a long document. It could be 300 pages long. And if we were to do it this way, the number used for our line numbering might become a little bit too big. And how we can overcome this is we can reset the line numbering each chapter. And I can do this by adding that behavior to where we have customized the chapter title formatting. Because in this command, what happens is every time the chapter command is run, this code here, which controls the text formatting, is actually applied. And I can actually add here the command reset line numbers. And if I do this, I'll just save it, jump back to the main.tex file and rebuild it. Every time now the chapter command is called, the line numbers are reset. So you can see now we have chapter 3 starts at line number 1. And the same for our other chapters. Chapter 2 starts at line number 1, etc. Now, I would also prefer that instead of us having to modify the document class to do that, that we can just set it as an option, set some option here called correctable, and it applies the correctable version if we want it. I'm just going to remove that. So in order to create this correctable option, we can just add some options handling code. and we can add the options handling code. Where is the best place to add it? The best place to add it, I'm just going to remove the comment for it. And I'm going to say we'll put it here after all of the require package commands. So I'm going to move this more declarations comment up to here. Okay, so now this section of our document class will be dedicated to options handling. How the options handling code looks is you use a command called declare option, and with this command we can create any option. So I'm going to give this option a name correctable, and here in code I put the code that will be run if that option is called. So basically what I do is I can now cut this, and I'm just going to jump the code to a new line, and then here I will paste that code. So now if the option correctable is called, this code will be run. Now if I use the declare option command, I always have to follow this with process options and then the command relax, so LaTeX actually adds this option. And I can also add the declare option command here with the star symbol, and this is typically used for the error handling. So how this works is any option which the user tries to input which doesn't have its own declare option command, so if I basically call any option that isn't the option correctable, then this code will be called. And typically what you do here is you put in an error message or a warning message, and I can do that with the command class warning, and then I have to put the class name, which is my thesis, and the warning text which the user will see is the option, and then I'll put in two single quotes the command current option, which will print to our warning log down here the current option the user tried to enter, and then after that I'll just have the text is unknown. Okay, so hopefully now that should work. The other thing I'm going to do while we're changing the line spacing is I'm actually going to set a default line spacing. So this line spacing will be applied by default to our document, but then if the option correctable is called, it is changed. So normally you put 1.5 spacing for a thesis. And now if I come back to our main.txt file and rebuild this, because I haven't set the correctable option, none of this code should apply. So we should lose the line numbering, as you can see. And now the line spacing is 1.5. But it should be now possible for me to set an option as correctable. And if I rebuild this, we should now generate the correctable version with the line numbering, as you can see. And we've also increased the spacing to be doubly spaced. And the other thing that should happen there is if I set some random option that isn't built into the class, like I'll try set an option two-side for two-sided printing. We haven't created this yet. When I build this, we should now get a warning message down here. If I come to the log, you can see we're getting the warning two-side is unknown. And I'm getting another warning because I've accidentally put a K down here, which I did not realize I had done. And we have this option, the option two-side is unknown, and that message is being printed by this class warning command. Now, the next thing we'll look at here, and the final thing which we will end up looking at as well, is how can we modify our thesis to generate a version which is suitable for two-sided printing, as well as one-sided printing, as well as one that's suitable for online publication. And the difference here is just in the page margins. If we are going to create a two-sided or a one-sided version, these will be printed, because those are defining how you want it printed. Do you want it printed on both sides of the page or one? And depending on which way we go, we need to set the page margins up differently to account for the binding. You can see here, this is a notebook with a binding, and we need to add some space where the binding will exist. Now, when we add this code, we also want to easily be able to switch between whichever one that we're trying to create. So what we'll also do is we'll add this functionality to the options handling. So I will create an option called two-side, and that will then set our document up for two-sided printing. I will also create an option called one-side to do the same, and we can even create an option called online to set our pages up for online printing. Now here I actually have our thesis open in Sumatra PDF, which can be quite useful for looking at, is our PDF suitable for being printed? And here I set the view up to book view mode. And as a result, this will show the front page is just on a single page. So it's like if the book is closed, you would see one page. But if the book is open, you see two pages. You have your page here on the left, and you have your other page on the right. And in book printing or Print It Works, the left page and the right page are commonly referred to as the verso page and the recto page. And the normal convention is that the recto page has odd numbering. So you can see here we have page number I. We actually have an error here that we should have a blank page, but it's printing page number 2. So we'll have to get rid of that. And if I come down, the other normal convention is chapters start on an odd numbered page. So they always start on the recto page. So if I come down here, our chapter is not on the recto page. We actually have an error here because I should have page 1 on the right hand side. So if I don't have that, we might run into issues when we try and print this correctly. Now the other trouble here is that, as you can see here in our front matter, the inside of what we're looking at here is the inner margins, because you now have your book opened, assuming of course this is two-sided print. You have your book opened, there's you see 2 pages, the outer edges are your outer margin, and then you have your inner margin. So if we were getting this printed two-side, we need to allow our inner margin to be larger, versus if I change the view here to single page, if you were then getting your thesis printed as one-sided print, then what you would do is the inner margin would always be the left-hand side, because you would print this text on the front of a page, the back would be blank, same for the next page. So then basically the binding would always be on the left. And then what you need in that case is you need your left margin to always be bigger than your right margin. But here we would refer to it as your inner. So your inner margin is the one where the binding is. And if it's two-sided, it alternates each page. And if it's one-sided printing, it's always on the left edge. And then the other thing here is if you're actually putting your thesis online, you're not getting it bound, and you actually want it set up as we currently have it set up, where the left margin and the right margin are equal, because then it just looks more aesthetic to the person who is actually reading it online, as we are kind of doing in this setup. So let's jump over to Text Studio, and let's first correct this issue with page number 2 here. So I'll, in Text Studio, scroll to where that error is occurring. So we have page number 2 down here. How I'm going to correct this is I'm going to modify the title page command, which we defined in my thesis, or the make title command, I should say. So I'm going to come down to the make title command, which is here, and I'm just going to add to its definition. I'm going to use the command page style empty, and that should remove the page numbering from this page, but it will also then remove it throughout the document. So if I add the page style empty here, I'll just save it and run it to show you that it will remove the page numbering, but it will remove it on the next page also. So now we need to get the page numbering back, and to do that I'm just going to modify the front matter command here. So I can add a command after this as page style plain, and that will bring the page numbering back. And for consistency, I'll add it to the main matter command as well. So if I rebuild this now, we should get the page numbering back. So you can see now in our front matter, we have the page numbering again in Roman numerals. And if I come all the way down to where our main matter was, you can see we still have our page numbering in Arabic numerals. Now, the next thing we'll go after is we're going to modify our page margins so that we can set an option here for two-sided printing, as we have already written. So that option is currently not defined, so we should actually be getting a warning as we are. If I come to our my thesis document class file, I can add to the option handling code. So here I can add an option for two-sided printing. And again, I'm going to use the declare option command, and I want to create an option called two-side. And here we'll put the code for that, and I want to do a similar thing for online printing, or I'll just say an online version. Of course, there's no such thing as online printing, just an online version. So in that case, the left and right margin should be even. So that's as we currently have it. So I actually want to do nothing, but I will still put this command just so this latter part here with the declare option and the star doesn't end up triggering the warning message. So I'll just leave that space blank, and then I want to create an option for one side, which will be for one-sided printing, and two-side for two-sided printing. And so we need to figure out the code that is going to go into these blocks, which is the code that would be run for each of these options. Now, what I actually want to change here is basically how the geometry, how the margins are set up in the front matter and main matter commands. So as a result, I'm going to change here, instead of using the command geometry, I'm going to create a new command called front matter geometry, and I'm going to do a similar thing below here. So instead of using the new geometry command, I'm going to comment that out, and I'm going to use a command called back matter geometry. And then what I'm going to do is I will cut this code. So that is our front matter geometry in, if it was an online version of our thesis. And I'm going to come to our section before the options up here, where we're basically setting some defaults. So we set the default spacing, and then below that, I'm going to set the default geometry. And the default geometry, we can set it by creating a new command, which was the command front matter geometry. And then for its definition, I'm going to paste that code with the new geometry command. So as a result, by default, this command, front matter geometry, has this definition of set our pages up for even left and right margins. And similarly, we have the same dimension for top and bottom, but they're quite wide. And I also want to repeat this for the back matter command. So it was back matter geometry. And then for its definition, I just want to paste the other geometry setting, which was down in the main matter command here. Oh, sorry, I've got the naming wrong. I shouldn't be using back matter. I meant to write main matter here. Okay, so we have our two commands, front matter geometry and main matter geometry. And these commands will have the default values defined here. So we front matter geometry are those dimensions, and then we have main matter geometry is the narrower dimensions of left and right are 2.5 centimeters, top and bottom are 3 centimeters and 3 centimeters. Now, the reason I have decided to create these commands is because I can now basically redefine them in our options. So when we declare the option one side, I can now redefine our command front matter geometry, and then as a result, when the command front matter is ran or the command main matter is executed in the main.txt file, the commands here, main matter geometry and front matter geometry, will have the correct definition for those options of one-sided or two-sided. So to finish this off, what I will do is I'll come up here to the one-side option, and in this section now I put the code that will be ran if we want that one-sided printing. And in that case, what I'm going to do is copy this code where we're setting the default geometry and paste it down here. And now instead of using new command, I need to use renew command because these commands will have already been created. And now I can just change the geometry command for one-sided printing. And what I can do here is, or what I should do here is, instead of setting left and right, I should instead set an inner and an outer dimension. And to create space for the binding, what I will do is I'll just add a centimeter to the inner. So instead of 4, I'll go with 5 centimeters. And then I'll repeat this for the main matter geometry. So instead of left and right, I'll use inner and outer. And to create space for the binding, I will add a centimeter. So instead of 2.5 centimeters, I will use 3.5 centimeters. And then I'm going to copy this code. And for two-sided printing, we're going to do a very similar thing. So if the two-side option is called, this code will be run. And again, for two-sided printing, we want to use an inner and an outer margin. But what's going to be slightly different here is I can actually call an option called two-side from the geometry package. And if I use that option, it will basically alternate the page margins. So one page, it'll be the left-hand side is the inner, and then on the next page, the right-hand side, and so on and so forth. And those options are now defined, so this code should work. So if I come back here now to our document class and I run this code with the two-side option, hopefully it builds. And to check it's worked, I'm going to open this in Sumatra in the book view so I can actually check it. And what I'm looking for here is, because I've set two-sided, there will be text on either page. So I'll open it up and I can see the verso page here and the recto page here. So this is the verso, this is the recto. And basically what I want is the inner margins here are bigger than the outer. So we have that correct for the front matter. And I just want to verify that it's also correct down here for our main matter. So this is actually working. And you also just want to check that your odd pages are on the recto page, the right-hand side page. So that looks to me that it is set up correctly. And we can also check here, is the one-sided option working? So I can set the one-side option. And if I build this and I come back to Sumatra, here to verify this is set up correct, instead of using the book view, I'm going to change it to the single page. And now as a result, in the one-sided printing, we should always have the binding on the left edge. So that means that our left margin should be 1 centimeter bigger than the right. So that's true here, and it's true again on the next page, and it continues being true all the way down to the main matter, and it's still true. The left margin is wider than the right margin to allow for the binding. And as a result of setting up our code this way, it is really easy to switch between one side, two side. I can go online, and then we'll get the even page margins on the left and the right, as you can see here. And of course, I can combine options and say I want an online correctable version, and that will change it back to that correctable option, which we defined in an earlier part of this video. So now we have our online correctable version. And with those options set up, I will conclude this lesson here. This lesson also concludes this section. I hope you have enjoyed watching these lessons. Be sure to check out our LaTeX Complete course. Click the promo video here to check out the complete course.